Welcome back once again to GH Electrical Engineer. I trust you are all doing well. A brief update about earthing system or a grounding, or what do I need earthing system or my domestic installation, or what do I need earthing system or my commercial or my industrial installation. Guys, let's dive in. What is earthing system? It's a system that provides human and animal safety. It's simple. I think it's a very simplicity. It's a system that provides human or animal safety. So earthing is all about your safety. We have a different way of earthing. In Ghana here, we use TT system, and I think in Europe they have a different system. We have TNS and TNCNS. All of them is part of it. I have to cover another video talking about all of them. So in Ghana, we really use TT system. What is TT system? It's a terror earthing system. So what is a terror earthing system? It's a system that allows you to have your own dedicated earthing system. So TT system in Ghana here, it allows you to have your own dedicated or your own independent earth rod or earth electrode on your own home. So we have a system that provides you that earthing is there. But this system is not providing you, but it's giving you, it allows you to provide your own dedicated or your own independent earth rod. So that is why we are doing it right here for our client. So we got a challenge. We got earth. So how much is it going to cost your earthing system? It depends your soil resistivity. So that is what we are facing here. This client used to have a very gravel area. So finding them is not easy at all. So guys, we are back in finding it. It was not easy at all. But nothing we can do about it. Nothing we can do except that we need to do a necessary thing so that my client can get good earthing. Because when you have a good earthing, it must be a less ohms, less than 1 ohms, or even a single digit. It's okay. It's good to go. But in here, we face a lot of challenge. A lot of different challenge. That is why we are about to show you, so that if you match your electrician, those who are in terms of building or those who are in the process of the building. So, let's see. An earth resistant or a good earthing must have a less ohms or a less resistance, and you need to test it. Make sure that your electrician tests it and find out that you have a less resistance. If it doesn't invest in machines, your electrician have to invest on a lot of machine to test a soil resistivity, so that we can know that your earth installation is perfect earthing. Right here, you can see this is an installation earthing right there. We have installed it. It couldn't work properly, so we decided to treat it by chemical, or we decided to extend it by bury another earth rod. So right there is earthing. We also bury another earth rod, which is a 6 feet earth rod right here. It's 8 feet. When you see that again, it's 8 feet. Another one is right there. We bury another 6 feet earth rod. Guess what? Not only this, 10 meters away from that place, there is another pit right there. We also bury another earth rod. It's headache. From 5 meters from that place, let me go there and show it to you guys. Another right there is also another pit for 6 feet rod. So you can see from this side, it's not easy at all. It's not easy. Installing earthing, not easy at all. Sometimes when you find yourself in a very gravel area, it never go easy for us. So guys, you need to match your electrician to do the right job on your site. And guess what? We have invested a lot of machines. So as you can see, this one is the main installation for our electrical wiring. But we got a high resistance, and it have to be low resistance too. That is why we decided to bury another electrode. And then what we are using here, we have a temporary cable. We got a machine, we got a potential cable. So what we are doing here, this test called soil resistivity test. We are testing the electrode by its own soil. So that is why we call it this test. It's a soil resistivity test. We are testing the electrode by its own soil. That is why we invest in a lot of machine to bring the best for the clients. So what we are doing here, we are going to test all the 3 electrodes to find what we are going to get. We are invest, as you can see, we got potential cable, we got a current cable, and we got electric cable, which is also connected to the main electrode. So let's do a test, and then let me get myself a paper, at least if I do the test, and then let me show it to you. We press the button, and we got approximately, is this 75.4? Let's make it that way. 75.4, which is a high resistance. It's really high ohms. It's really, really high. No good, very bad earthing. Very, very bad earthing. And then that is why we also increase another electrode. So we are going to join this electrode by a temporary cable, which is, we are going to use 60 millimeters square to join all the cable, but now we are doing a temporary cable. So the first one we got, so my guy is joining the cable, which is another electrode that we bury on the earth plate, to join it and see what we are going to get, because we want a good for the client. We want the best for the client. Though we are wasting money right here, but we need to spend the money sufficiently. So we are joining 2 temporary cable, 2 electrode, one right here and another one right there. We are joining them and see whether we are going to increase or decrease. Whether we are going to increase or decrease. Guys, we need to match your electrician to do the right thing, because we are invest a lot in our electrical industry. Not only GH, a lot of people out there too. So we do another test, and you see, approximately we got 46.3. 46.3. You see, we lose over 30. We lose over 30 ohms, which is, we need less than a single digit. It never come easy at all. So we also go back to the 5 meters away to do another digging. So let us also join them and see that three of them, what we are going to lose. Oh my God, this is a different separate area, those things that you see right there, but we are going to join these 3. After we done this, he connecting the temporary cable, which is a temporary cable, connected it for me to test it and find out what we got from here. We invest a lot of machines right here. Let's do the test and find out. Okay, press the test button. 46.3. No, it must be a mistake somewhere. It must be a mistake. It must be a mistake somewhere. Guys, check it out. Check it that place and let us find out. It must be a mistake. Let me test it. 46.3. Yeah, different. It must be a mistake, because another electrode have to be giving you a less ohms. Yes, it must be a mistake. Let me check this side and see. Let me check this side and see. Find out. No, I told you guys. I told you the cable down there is not joined. It's not connected to the electrode. It's not connected to the electrode. So let my guy join that place. Well, and then come and connect this cable. Let me show it to you guys. This cable is right there. It's not connected to the electrode. Yeah, that is why I still get the same digit. Because we know definitely it must be a little deductions. It must be a little deductions. It must be a little deduction. It is really important because earthing system is a system that provides human and animal safety. So it's really, really important. And it has to be a less ohms. That is why. So let's do a test and see. So you press the test button and see. It's reading. It's reading. Let me say 29.7. That is 29.7. So this is a different earthing, 3 different earth pit, and we test them by a soil resistivity test. So when we do them, we got so far a 3 different earthing. We got 75.4, which is a very high resistance. We got 46.3, which is a pretty high, and also 29.7, which is a pretty high. We are not still satisfied about this result so far. So that is why we continue to do a more digging in the house, because we have to bury more earth rod. So what we are going to do, this side, we are going to test this side, 2 of them right there. So we are going to test, we are going to bring the machine to that place, and then we take all the potential cable and the current cable to the opposite side and test it. Because what we are doing, the test that we are doing, what my guys is doing, as you can see, is using the potential cable and the current cable to unplug. You can see on your screen how this test is done. You can see on your screen. It's really, really important. As you can see, right there, we got over 10 meters away for another digging, and we also got 3 meters away for another digging. And this digging, we dig over 5 feet, 5 feet, and 5 feet with a earth rod, 6 foot earth rod, 6 foot earth rod. It's not easy at all. It took us 3 good days to do this work, to execute this work, only earthing. It never come easy at all. It took us over 3 different good days to do this. So what my guys is installing, he installing a potential cable and also the current cable for the machine, so that I can put the machine, the earth rod cable, to connect it for the test. When you have a good earth system in your home, any fault or any fault current flow into your electrical system will direct it to the earth. That is why this is really important. Any kind of fault, anything that had a shock or a fault will directly to the earth. You can see we are about to do the test. Now we got 3, we got 75.4, we got 46.3, and then 29.7. So that is what we got so far for the 3 different earth location. So let's test this and see what we have to get to. Okay, we press the test button. We got 1 ohms or 1 resistance. So we do another test again. We got 1 ohms. You can see it on your screen. This is what we are looking for. This is a good enough, and this is a good for our installation. This is a good for the parish trace, which is called bonding. We're going to talk about a quick brief update about also bonding, something that we call it bonding. But this is an earthing system or a grounding. As you can see, this is what we have tested it so far, and it's really, really good. It's really, really important to invest on your earthing system, because earthing system is really, really important. What is important of the earthing system? One, earthing system will make your electrical appliances free shock, especially kitchen deep freezers, electric oven, heat extractors, those things, anything in your kitchen that used to be happen to have a faulty will not shock you. So you can walk free on your own kitchen because you have a very good grounding. It gives you more encouraged to walk free in your building because you know that they have provided you a good safety. So that is why we need to have a good earthing system. It's really, really important. So what we are going to do, we are going to test another one and see. So I think one of them is all your equipment is free in shock, electrical shock. All your equipment is free. Because any faulty that happen in your wiring will pass through the earth, or will pass through the earthing system. Because the earthing system that play have a low resistance. A low resistance. Another one too, it provides you alternative path of the dangerous fault current that flow through that will flow through the general mass of the earthing. Any fault in your electrical installation, or any fault that happening on your fridge or your deep freezers, if you happen to be touching it, that power have to flow through you. But if you have a good earthing system, that fault or that power will flow through back to your earthing system without shocking you. So the main building earthing installation will go right here, and the main story building too will go other side of the earth rod. It's good. Even ECG, you see where you drag your meters, you see, or you can see the cable on your the pole. I think on your screen you can see the ECG cable there. The force can come in, and it happen to come into your home. When it come up home, most of the time it damage your equipment and those things. When you have a good earthing system, that force coming from the ECG will directly that earth will direct them to the earth. That earthing system will definitely attract them, direct them to the earth. Because always force happen to the ECG lines. So that is why you need a dedicated earth rod to be buried. And when you bury them, make sure that they are in the less ohms. Because in Ghana here, we are using TT system, which is a terra earthing system. And that TT system is a system that allows you to dedicate it on your own earth rod or your own independent rod. So what we are doing right here, to do another test for another soil resistivity test with another earth pit. So somebody may say that is a heat again. What are we going to do with that? So what we are going to do is that we have a timbers. What is an earth timbers? You can see one on your screen. Earth timbers. So we are going to put it there to finalize the final screening of the compound. So no problem at all. All of them, you are going to close it and put this one right there, so that it will finalize the compound, the compound filling or the compound tiling. It will match with the compound tiling, because the earthing system have to be checking it by periodically, because it can lose ohms. The ohms can be high. That is why we are testing it in very dry day. We are testing it in a dry day, because when you test it on the rain day, it happens to be a less ohm. Meanwhile, it's not like that. That is why we are testing it by a dry day, because we want a good for our client. We cannot risk their life. That is why they need to get a good earthing system. Because earthing system, it provides human and animal safety. When you don't have a good earthing system in your house, it means that you don't have a safety. It's better to have it. It's better to have a good earthing system. And some people may decide not to bury more earth rod, but they'll rather go for earth sun. Because we have earth sun, I decided to bury more earth rod. So as you can see, we connected the potential cable to the earth rod right there. So we are coming to do a test and find out with the other opposite side of the earth. As you can see, let us press the test button. You see, it's good. It's good to go. It's good to go. It's a happy days. It's good to go. So we got a less ohms. Let us turn it back again and see. Another test. 1 ohms. Good to go. It never come easy. We have spent almost 3 solid days for just to get a less ohm for the client. Never be easy. So what we are going to do, we are going to give a 60mm square cable or 25mm square cable copper conductor, drag them to the side to install them, and then we put an air chamber like this to it to make sure that you're doing a right thing. Thank you guys. I think this is very useful to you. Like, subscribe, hit the notification bell so that you always be aware when GH uploading the video, you'll not miss out. Guys, I will see you next time.